Good afternoon, everyone, and welcome to Wassa Distance Education. This is MBF3C, Grade 11 College Preparation Mathematics, and my name is Marvin. Welcome to class number 15. We are in week 4, approaching the halfway point of the course. We are working on lesson number 7, which is compound interest. Marvin.osmond@nnacschools.org or 807-738-2031 are ways you can get in contact with me. Email, text, or phone call, whichever is more convenient for you. I'm usually up by 7 in the morning and I'm usually in bed by 10, so anywhere between 7 a.m. and 10 p.m. would be fine. Email, you can email me any point. Texting, I don't bring my phone to bed, but it's on my office desk and I'll check it in the morning when I get up. So lots of ways you can contact me. As you can see on the screen, there is text in blue. As I have explained before, anything that's in blue or red. Blue is new material, new notes, just to augment what's already in the lesson that you would have received. So hopefully it helps clarify or explain better what you've already received. And then anything that's in red would be problems, sample problems that we solve on air, and I put those in red so you can clearly see it's the solution. If you're watching the YouTube channel, that's great. You can see the video, you can follow along. If you don't want to follow along and you just need a little bit of help and you just want to see the text, you can email me or call me and I can get you a copy of the document that you see on the screen right now. And again, it will be in blue and red. So when you get it and you go through it, you'll know what's new and what's not. Let's do a quick review. So yesterday we looked at the compound interest formula, A equals P times 1 plus I to the power of N, where A is the final amount. That's the amount at the end of the period we are interested in. The initial amount or the initial principal is P. I is the interest rate per period, again as a decimal, and N is the total number of compounding periods. So I put a little table there to illustrate the little formula that we would use for I. I is the interest rate per year divided by the number of compounding periods per year. So it's compounded monthly, we divide by 12. Compounded weekly, divide by 52, and so on. Yesterday, I put up the table. If I come back up here, I'll show you that table again. So compounding periods annually, semi-annually, quarterly, monthly, semi-monthly, weekly, bi-weekly, and daily tells you how many times each of those will be compounded in a year. So that particular table you might have to refer back to if you're not sure. Feel free to do that. And then N is the total number of compounding periods, and that's found by the number of compounding periods per year. So again, right from that table, times the number of years. And we did some examples yesterday. I think we did 5 examples where we did compound semi-annually, weekly, annually, daily, monthly. So if you're solving problems, again, follow this pattern for the solution. Step 1, find I. Step 2, find N. Step 3, do the substitution into the formula A equals P times 1 plus I to the power N. Do the calculations and then solve for I if that is required. Not always required. If it is, then you follow this. But 1, 2, 3, 4. If it were a word problem asking you a question, we would put a statement and answer that question at the end. There's no questions here. It just says determine, so we don't have to write a statement. Okay, so there's a quick review of what we did yesterday. So now we're going to take a look at a problem, sample problem 7.2. Cindy is considering investing $36,000 for 5 years at an interest rate of 7.5%. And again, that would be, I should put that in there, per annum, which means per year. Complete the table for the various compounding periods to determine which one she should choose. So should she choose annually, semi-annually, quarterly, monthly, weekly, or daily? So we're going to work through each of these examples and then determine which is the best one she should choose. So let's look at the first one, annually. Annually means once per year. So I is going to be the interest rate, which is 7.15%. And again, to change that to a decimal, we need to divide by 100. So 7.15 divided by 100 is 0.0715. So the annual interest rate, I, is going to be 0.0715 divided by, if we're compounding annually, that means once per year. So that divided by 1 is itself 0.715. N is the number of interest periods in total. So the number of interest is going to be 5 years, and annually means once per year. Okay, so once per year, I'm not sure what's going on there. I'll get that. So 5 times 1 is 5. So now we have our I value, we have the N value. We now simply plug those numbers into the formula. A equals P times 1 plus I to the power of N. The P value we get from here, which is, get over here, okay, got to draw. P value is $36,000. 1 plus I is 0.0715 to the power of N, which is 5. Again, do the addition, do the exponent, then multiply. And again, I'm going to double check to make sure that I'm using my calculator properly. So I'm going to go 1.0715 to the exponent 5 times that by 36,000. I get 50846.7709. Round that to the nearest penny. So the amount would be $50,846.77. The amount of interest earned is going to be that value, $50,846.77, minus the principal amount, which is $36,000. And interest works out to be $14,846.77. So that's if we were compounded annually. So what happens if we compound it semi-annually? Semi-annually means, so annually is once, semi-annually, I don't know why it does that. Let's click on annually is once. Nope, I don't want that. And then, so it should just write over top like we did up here, but maybe because it's in the table. Semi-annually means twice. So I'll just put it here for now, twice per year. So that means we're going to take the interest rate of 0.0715, divide that by 2. And if I do that, I'll get 0.03. So let's do it. 0.0715, divide that by 2, and I get the number 0.03575. The number of interest periods in total, N, is going to be 5 years, and we get it twice per year. So 5 times 2 is 10. So that means there's going to be 10 compounding periods. Now let's put that into the equation over here. So 36,000 will be the same in all of these because we're looking at the same amount, 36,000. So now I'm going to do the math. Times 1 plus 0. We just found this number from here. So now I need to add the 1. So plus 1 equals. Now BEDMAS says do the exponent next. So to the exponent of 10. And then times that by 36,000. And I'll get 51150.7399. Round that to the nearest penny is $51,150.74. The amount of interest will be that number, 51,150.74 minus the 36,000 we started with. We'll end up with interest of $15,150.77. Okay, let's take a look at the next one if we compound it quarterly. Quarterly means 4 times per year. Okay, so 1/4 is 4 times per year. So now we're going to divide the 0.715, divide that by 4. And if you do that in your calculator now, 0.0715, divide that by 4, and I'll get 0.017875, which is not a large decimal. It's not rounded off. So I can use that number in my calculations. So I put the whole number right there. N, 5 years. Compounded quarterly is 4 times per year. 4 times 5 is 20. So there is the exponent 20. So now it's simply going to be a matter of doing this on the calculator. So I found my I value already, and it's in the calculator already. So I'm going to leave it there. Next part is to add the 1. So plus 1. BEDMAS says we're multiplying exponent. We do the exponent first. So now we do exponent 20. And then times that by 36,000. 51,308.75265. Round that to the nearest penny. And you'll get $51,308.75. So to find the amount of interest, you're going to subtract 36,000 from that amount. You end up with 15,308.75. So we've done 3, and we have 3 to go. So the next one is going to be monthly. So now it's going to, I'll just come down here, so we'll keep it. The other one's hidden for now. Same thing. So monthly means, if you go back up to that table, if you don't remember, 12 times per year. So 0.0715, divide that by 12. Now I get a number that's repeating. I don't want to round the numbers off because when we're doing these sorts of problems, you round in the final step. So we're not going to round here. So we're going to leave that number, 0.0715 divided by 12 in the calculator. We're not going to write it down. 5 years times 12 times per year gives us 60 compounding periods. So now let's do the math. We put all those numbers into the formula A equals P times 1 plus I to the power of N. So we've already done the 0.0715 divided by 12. Now we're still inside of the bracket, so we do the plus 1. Then we need to do the exponent 60. And then we have to multiply that by 36,000. I get 51,416.44681. Round that to the nearest penny, and you'll get $51,416.44. So to find the amount of interest earned in 5 years, compounded monthly, we subtract 36,000 from that amount of 51,416.44, and you'll get $15,416.44. So, so we're doing quite a few examples just to show, okay, how to do each one. So now you should have lots of examples to follow and do them. When you do your key questions and your support questions, do them just the way that I've done them here. Don't leave any steps. Okay, do all the steps. So the first step is to calculate the I value. Again, we're always starting with 0.0715. So 0.0715, divide that by 12. Okay, we just did that one. Let me start. So now we're doing the weekly one. So that means we have to, if you don't remember, go back to the table. There are 52 weeks in a year. So now we need to do the interest rate of a 0.0715, divide that by 52, and you'll get 0.001375. Uh, let's do that again just to make sure that's right. So 0.0715, divide that by 52. Yeah, I get 0.001375. Now, that number is not rounded, so I can actually use that number in my calculations if I wanted to. For now, I just left it as a fraction. And then I can do them all the same way moving forward, just using the fraction, and it's one less step in the calculations then. So it's going to be 0.00715, divide that by 52, add on the 1, plus 1. Now, if 5 years and there's 52 weeks in a year, so that means there's going to be 260 weeks in total. So my n value is 260. So now to the power of 260. And then I need to times that by 36,000. Works out to be $51,458.38 because 0.38292 rounds to 38. So the amount of interest earned will be that amount of 51,458.38 minus the 36,000, which works out to be $15,458.38. And the last one would be daily. So daily, there are 365 days in a year. Now, this one, if we can be rest assured, we're going to get a number that's going to be rounded for sure. So we're going to do 0.0715 divided by 365. It's going to be a really small number. So I get 1.958904411 e to the power negative 4. So that means it's a really, really small number. That's all you need to know for that. So leave that number in the calculator because that's the first part inside of the bracket, do the division. Then we have to add on the plus 1. Now, 365 days in a year times 5 years will give us 1,825 days. So that's going to be to the power of 1,825 to the power 1825. Gives me 1.429700515. Now I need to multiply that by 36,000. And I'll get 51,469.21838. Round that to the nearest penny is $51,469.22. So now to find the amount of interest, I subtract 36,000 from that amount, and I'll end up with $15,469.22 in interest. So now we've done what I'm going to do now is I want to see all of these on the screen at the same time. I'm going to make this a little smaller so that I can get all of the, oops. Okay, So now I've got all of them on the screen. So annually, semi-annually, quarterly, monthly, weekly, daily. So what you'll notice is that the amount of interest earned here was 14,846.77. And for some reason, this does not want to cooperate today. So I'm just going to do it this way, go back here and see if I can't do it this way. So the amount of interest is 14,000. So if I were to do the investment, so this is an investment. So because it's an investment, I want to earn as much interest as I can. So I want to maximize my profit. It's earned the most interest that I possibly can. So the interest I earned here was 14,846.77. Here, the interest was 15,150.77. Here, 15,308.75. Now you notice that in each one of these, the values are going up. So 15,416.44, 15,458.38, and 15,469.22. So what you can see here, if everything else remains the same, so we'll get the same interest rate per year and the same amount, and I simply change the compounding period. So what I'm doing is I'm just changing the number of times it's compounded per year. The more times that it's compounded per year, the larger the interest I'm going to earn. So in this case, if this were but the problem we're given is which one would you choose? Because this is an investment. So I'm going to choose, I'm going to try this again, see if it will work this time. I will choose this one here, compounded daily, because that gives me the largest amount of interest. So that's where I'm going to earn the most. So I'll delete that. Okay. So there should be what we should have done here. Cindy is considering investing 36,000 for 5 years at an interest rate of 7.5% per year. I'm going to get rid of these little black marks as well. And I don't need these values to be, let's go home here. And it's no color. So we don't need these to be highlighted anymore. Okay. So what we should do now is answer, oops, undo that. What we should do now is answer the question. Complete the table for the various compound periods to determine which one she should use. So here, I'm going to come outside here, and I'm going to say, I don't want it. Cindy should choose oops, to invest her money compounded daily, because that's where she's going to earn the greatest amount of interest. I'm going to make that a little bit smaller here. And I'm going to change it to Cambria, which is the text that we've been using. So Cindy should choose to invest her money compounded daily. So we've done the calculations, done the comparisons, and now we've answered the question. Okay, so we've done many examples now. So you should have seen enough examples to help you get through all of the support questions, or most of the support questions and the key questions as well. The next part here, we're looking at graphing. So when we graph, and we're going to use Desmos again. So I have Desmos up and running here. I'm just going to get it up on the screen so that I'm going to just minimize this, and I'm going to, oops, get out of here. I'm going to lock this to the left-hand side of the screen so it stays there. So now I'm going to bring up my Desmos, and again, desmos.com is the program online. It's free to use that we used. Oops, I want to do that. I want to do this. So it does a very good job at graphing. Okay. So exponential growth, remember we looked at that, and it is a curve. It is a curve that goes up to the right, doesn't cross the x-axis. That's what we mean by exponential. When we look at simple interest, because there was no powers, we had a linear relationship, which was a straight line. So what I want to do now is I want to compare this one right here. If we invest $100 at 8% per year, compounded annually. So what I want to do before I do anything here is I want to do simple interest first. Okay. So simple interest, if I do simple interest, that would be $100. Remember, I equals P times R times T. So if we look at simple interest, I'm just going to come down here. This, so I'm going to put this in red, simple interest. I'm just adding this right now. So if I do simple interest, actually, I'll hang on that. Whoops, where did it go? Oops, come down here, went back up. Simple interest. The formula is the amount at the end, A. I'll just insert a formula here, just an equation, and put it on the left-hand side there. Again, this is just something that popped in my head right now, so I'm just going to go through it with you. So A equals, that should be a capital A as well. A equals P plus I. Now I'm going to the I we said is, I'm going to just do the substitution. I is P times R times T. So I'll do it all at once. And then, so if I do this, I just want to show you something. And then the paste part. Here, just a P common, so I can common factor the P out. And then put a bracket, 1 plus, I've factored out the P plus RT. That would be how you would find the amount of simple interest in one step. Okay. If I wanted to do the compound interest, let's get out of here. I don't want to underline yet. Oops, I'll do that. And I'm going to tab over here and do compound interest. And then I'll underline that. That formula is the bracket right there as well. I'm going to copy that. Oops. So I made a copy of it because I want to show you something here. On why is it that? Oops. Get that back up there. Uh, Back up here. So the compound interest is 1 plus I. So the RT is replaced by I, and then we are putting an exponent on there. So if I go over to where's my equation editor? So I'm gonna maximize this for now. Okay, equation right there. I need to add an exponent, and the exponent is going to be n. So this formula basically derives from this one, okay, but it's just a lot of math involved. So I'm just going to show you how similar they are if we do the calculation for the amount all in one step without doing the PRT separately. We can do it all at once. So what I can do now is I'm going to do an example where I don't want to do that example there. I'm going to go take that from there. And I'm going to come down here. I'll go beyond this. So just an example here. What I want to do is I want to show you the graphs, but this doesn't do a very good job of illustrating what the graphs actually look like. So I want to do a problem down here. Uh, what we'll do is we'll do it on a new page. So Command Enter, and then I'll get down here. So this is how we do simple interest and compound interest if we have, uh, let's get back over here. What I want to do is I want to compare simple interest to compound interest. And here, for some reason, doesn't want to cooperate. That's okay. Okay, so let's change the text to blue here. And let's do a sample problem. So this will be sample problem number 7.3. We're going to go sample problem 7.3. So let's do a comparison. Uh, so let's do A. We don't need that bold underline. And we're going to graph. Okay. So we're going to compare 1,000. So let's do, I'll just break it down like this. $1,000 invested uh, uh, at 9% per annum. Okay. And what we want to do is we want to see how much money would be in the account at the end of each period. Okay. So graph how, sorry. Yeah. How much would be in the account, okay, using simple interest. Okay. And then we are going to do the exact same thing. Let's do copy. Do the exact same thing, but using compound interest. And we're going to do it exact same numbers and then compounded, uh, let's say annually. Okay. So we're going to use Desmos. So the solution is going to be done, oops, using Desmos. I don't even need to capitalize. Yes. Okay. It's going to be red, and we don't need it to be. Okay. And I'm going to use Desmos because it's a lot more difficult to do uh, on graph paper. So if I want to do this, and again, I'm going to put this in red, what would the equation be? So the equation is going to be A is equal to, okay, let's put an equation in there, actual. Let's insert an equation, put that on the left side, and make it red. Okay. A equals, and we're investing 1,000. We're using this formula right here. Okay. So A equals, should write the formula down first, like I said before. Copy, paste. You don't need to be there. Oops. Well, then I come down here. So now it doesn't want to. A is equal to P is 1,000 times 1 plus the interest rate is 9% of, so 0.09. And T, so that's going to be the equation because we want to know what's going to be at the end of each year. So we don't want to do all the calculations ourselves. So 1 year, 2 years, 3 years, 4 years. We want the computer or the Desmos to do that for us. So I'm going to try to just copy that. I don't know if I can and just paste it. So we're going to go to Desmos. Let's exit full screen, come over here. No, can't do a paste. So I'm going to go use that formula here. This one comes over to here. A equals 1,000, bracket, 1 plus 0.09 T, close the bracket, and there's the graph. You can see it is indeed a straight line. If I use the compound interest formula, so this one right here, and put that on the left as well. Here. And we'll just move it in so it lines up. with the other one. Okay, now it's simply a matter of doing the substitution. I'm just going to make a copy of that again. Try to paste it in here. So now we simply have to replace the P with the 1,000 value that we're looking for. And the interest rate is still going to be 0.09. So I can actually do that 1.09 because 1 plus 0.09 is 1.09 to the power of n. Okay, now, so let's put that formula into this equation. A equals 1,000 times bracket 1.09 bracket to the power of, so I'm probably going to have to use the letter N because I used, oh, sorry, T because I used the T up here just so that the computer doesn't get confused. Command here, oops, nope, don't want to do that. Where did I go? Over here. So, to the exponent T. Is, and I should be using, I don't know if let me see if I can use N and see if I get the same thing. Yeah, to the power N. So as you can see here, this one, the simple interest one gives us a straight line, and this one here, compound interest, gives us an, so you can see that after 5 years, simple interest would be 1450, but in simple interest, it's going to be more. Now, if I come up here after 10 years, simple interest is going to be, about 1896, somewhere around there. But look up here. Compound interest is going to be over about 2373. So quite a bit of interest. So after 15, if you shrink this out, you know, after 40 years, you'd only have less than 5,000 here, but over here you'd have 36, or well, about $32,000, as opposed to simple interest, you'd only have what, 5,000. So simple interest, compound interest grows much, much quicker. So that's why when you invest money into an investment, you would prefer compound interest because it grows rapidly, whereas simple interest just grows same pace every year, not much to it. Okay, so that's why we use compound interest. Okay, so there is what the graphs look like. And again, if you're online or you're watching the YouTube video later, you can clearly see. However, now I can't put that graph into the module or into the lesson itself. So that's why I said use Desmos. So the equations are there. You simply type those equations into Desmos and then go from there. So that is simple interest and compound interest. Support questions, again, if they say determine, just do the calculations. Second one, Karen purchased a $2,500 compound interest CSB or Canada Savings Bond with an annual rate of 4.25% and a 7-year term. Now, because this is a problem involving an individual and they're asking questions, you need to answer the question after you've completed the calculations. So don't just do the calculations and stop there. Answer each of the questions. So all of these, if you can do these here, then there will be no issue. Now, if you go to the end, I'm just going to grab here and come all the way down to the end here. So the support questions, you notice, I get right here, all the answers are provided. And not just the answer, the solutions to all of the sample problems, sorry, not the sample problems, the support questions. So if you do, what I would do is do each of the support questions, follow all the steps that I did online with you, or that are listed in the lessons, solve, then check the answers at the back. If the answers at the back match yours, then you're good to go. Okay. So again, all of the lessons will have, so there's answer to lesson number 6 support questions and lesson number 7 support questions are here. When it comes to the graphing, again, what's in the lesson, it's not a great depiction, so it's probably better off going to Desmos and then putting those numbers into Desmos and doing the graph that way. Okay. If there's any questions about any, for example, if you're not getting the answer that is in the module, or sorry, in the lesson material, you're not getting the same answers, and you have some questions you're not quite sure why your answers are not matching, or you can't get them to match, then reach out to me and I will go over it with you online. Okay? So that's as far as we are going to go today. We're not going to have time to pick up something new. Classes is just about over anyway. So we'll pick up from there next week. Um, Let me just go back up to where we ended today. Uh, and again, these lessons are all the new material that I've added are saved when I save each class. So if you want, let me just click on save here. So if you want a copy of the just the written material that I've added, then let me know and we can get you a copy of that. But for now, this is as far as we are going to go today. Thank you for participating in today's class, and I look forward to talking to you again next week. Bye for now.